example 9 of the quotient rule work or notes is going to look like this. So it's asking you to differentiate both sides. So let's see if we get the same thing using the quotient rule from one side and then just the trig rules for the other side. Hopefully we will get the same thing. So in this case, I'm going to start with the left side. And I'm going to write small because I know this is going to take up a lot of room. So here, d dx of 1 plus tangent of x over secant of x. So I'll start with the quotient rule. So that's secant of x. D high, the derivative of 1 is 0. Derivative of tangent is secant squared of x. Minus high, which is 1 plus tangent of x. D ho, so the derivative of the denominator is secant of x, tangent of x, all over, draw the line and square below, so secant of x squared. So let's see what I get there if I simplify a bit. First of all, one thing I notice is that I can actually factor out in the numerator a secant of x in both of the two terms. So here, that's one term, and the other term is right here. Both of them have a secant of x in it, so maybe I'll just factor that out from the get-go. So secant of x is going to give me then secant squared x, and then I'm going to distribute the secant tangent of x, or excuse me, the tangent of x. So we get the minus tangent of x minus tangent squared of x all over secant squared x. Whoa, whoops, some auto here. Why did that triangle show up all of a sudden? Secant squared x, that's a little bit better. So a set of the secants can cancel out. Let's see what else I get. I get definitely secant squared x minus tangent squared x minus tangent of x over secant of x. Now, the secant squared x minus tangent squared x, that's one of the Pythagorean identities, is going to give me a 1 minus tangent of x over secant of x, which is then 1 over secant of x. That's the reciprocal function here. So let's see, we get 1 over secant of x minus essentially tangent of x, which is sine of x cosine of x, divided by secant of x means multiply by the reciprocal, which is, cosine of x over 1. These guys cancel out, so I end up with 1 over secant of x is cosine of x minus sine of x. Okay, that's cool. That's the left-hand side. Let's see what happens when I take the derivative on the right side. So right hand, let's see if we get the same thing. dx of cosine of x plus sine x. So the derivative of cosine of x is negative sine x. And the derivative of sine x is cosine of x. And then I could rewrite that as cosine of x minus sine x. Oh, look, I think we got it right. The left and the right-hand sides give us both the same derivative. Now hit pause and try and do the same thing on the other side. Hopefully you'll get the same thing. Just two different ways of approaching it. And we're practicing our trig a lot, which is good for us. This is where I get. Let's move that over here. Ooh, I ran out of room here, I see. So similarly, you got to use the Pythagorean identity at this part here. I see this one plus this one gives me 1. That's where I'm getting that from. And then separating it into two separate things. All right, the last one I'm going to do is, it isn't an example that correlates with your book, but it's an important example nonetheless. And we're going to use your TI-89. So if you could please go on, if you need to pause the video, go and find your TI-89, then do that now. But first, we're going to just do it by hand. It says, find the equation of the tangent line to the graph f of x is equal to tangent of x over x at x is equal to 2. Now, it's not asking at 0, so it doesn't become 1. It's not the limit Sx. It's very tempting to do that. But no, we have to do it the long way. So in this particular case, we are going to find f prime of x. For me to be able to do that, I'm going to have to use the quotient rule. So ho, which is x, d high, which is secant squared x, minus high, which is tangent of x, times 1, which is the derivative of the denominator. Draw the line and square below. Okay. So I need to find it f prime at 2. So I'm going to substitute that in. 2 secant squared at 2 minus tangent at 2 all over 4. Substituting in a 2 here. This is not a nice number, so it's not like something, and let me put parentheses in here. So essentially, if you were going to do this by hand with no calculator, that is the slope. I'll just leave it like that. The other piece I need to find for me to write the equation of a tangent line is I also have to find f of 2 to help me do that. So that means f of 2 is going to be the tangent of 2 over 2. Again, not a nice value, but I have the slope of the tangent line and I have the point of the tangent line. The point is going to be 2 comma tangent of 2 over 2. So to write the equation of the line, it's going to look like this. Y minus the y value, which was tangent of 2 over 2, is equal to the slope at 2 is going to be 2 secant squared of 2 minus tangent at 2 over 4 times x minus 2. Now, free response on the AP exam, you would be done if you didn't have to use the calculator. But we're going to practice using the calculator. So I want you guys to dig out your calculator and we're going to try. I have to use a different program. So looking at the graphing calculator, we need to, first of all, we got to get the function in there somewhere. I'm going to try and show you 2 ways of finding the derivative. I'm going to start with the graphical method. So going to y is equal to, it's above f1. And the tangent button is right above the letter T in blue. The arctangent is in yellow or lime or whatever color you want to pick. But there's also another place where it has all of the trig functions. If you go into math, which is above the number 5, that's the blue button and math. Go down to the trig functions. That's A, arrow to the right. It has every possible trig function you would need, even the cosecant, secant, all of those, cotangent. So I'm picking number 3, or you could use the shortcut, enter. And then we have tangent of x, n parenthesis, divided by x. That was my function. And what I like about entering it here is that it should look like it does on your paper. In this case, it looks right to me. So then we're going to go to the graph of this. So there's a way to find derivatives at certain values on the graph. That's very neat and very quick. So to graph it, I'm just going to hit the second F3 because above the F3 button it says graph. The graph is there. I would like to find the derivative at x is equal to 2. That's what we wanted to. So if you look at F5, that says math in the menus up at the top. So F1 is tools. F2 is zoom. That's the traditional from if you did it zoom on your old calculator, the 84. F3 is trace. Then we have F4 is regraphing if you wanted to have it regraph it again. And then F5 is what we want. We want math. And choice number 6 is finding the derivative. I'm going to choose that, enter. But you can type in the value you want it to find the derivative of. So I'm going to just type the number 2 because that's what I want. So see down there where it says XC bottom left corner, I type the number 2, hit enter, and it will actually give you the derivative at x is equal to 2. So my derivative right now is 3.433. Now on the AP exam, you have to use a minimum of 3 decimal places. If it is a calculator question, a minimum of 3 decimal places. You could do more, but do not do 2. If you do 2, they will give you 0 credit for it. Okay. I also need to find what the actual value was. So that's what I like about this. I can hit the home button, and then I'm going to use function notation. I'm going to type y1 of, I want to find it at 2, like so. And, oh, wait, it gave me, that's not very helpful if I want it as a decimal. But if you look above the enter button, there is the approximation symbol in yellow. That means hit the diamond and then enter, and it'll give it to you as a decimal. So I got negative, if I'm using 3 decimal places, negative 1.09093 it would be. So now I have my values. Now, mind you, technically it's not the exact valued answer, but if it is a calculator portion of the exam, you may round to 3 decimal places and they accept it as the exact valued answer. Now, if it's a non-calculator portion, do not give me decimals and round and tell me it's the same value and I told you so. No, 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 no. It's only for the calculator portion of the exam that they accept that. And the same for me. All right. So on the graphing calculator, if you're using the TI-89, we found that f prime of 2 was 3.433 and f of 2 was negative 1.0393. I wrote here on the side the steps to take to find those two using the graphing function for derivatives, and also how to find the value of the function even if you wanted it as a decimal. If you're doing this on a free response, you have to justify that. So you actually have to show at the very least these values right here. If it asks you for the derivative first, then you would have to find the derivative. Your calculator can also do that as well. But if it's just asking for the derivative at 2, show the notation for that. And then you go into, okay, the equation of my line would then be y minus a negative 1.093. So it becomes plus 1.093 is equal to 3.433 x minus 2. And that would be the equation of the tangent line. You wouldn't have to do anything else. There is another way. If it's on a multiple choice and you just want the tangent line on the multiple choice and it's a decimal tangent line, your TI-89 can find the equation of the tangent line directly on the graph. Now the problem is directly on the graph is that it only works for multiple choice because in the free response you have to justify your steps. So you would have to show those pieces that I just highlighted. But if it's a multiple choice, the easiest is just, and I'll show you this right now on the TI-89, so I just have to switch over here. So we're back here with the function still in. Go to the graph, and then, oh, I did it already, but if you go to F5, and go down to, instead of finding the derivative, we are going to find the tangent, which is choice A, and hit enter. And then choose the x value. So I'm going to type the number 2 and enter. And down at the bottom there, it actually gives you the tangent line in slope-intercept form. So if it was a multiple choice, most likely they would have it in slope-intercept form. You could just look down here at the bottom. Oops. Down here at the bottom, oh, there is the tangent line. But I'm just going to caution you, don't rely on this only because if it's a free response, you have to justify the pieces. So you can't just go to that and be like, oh, my calculator gave it to me. That's not good enough. So in blue here, I have the steps for the TI-89. written out if you just need the tangent line. And this is the purposes of this would be really just for multiple choice, right? So you don't have to justify any steps. You can find it by graphing the function first. Step 2 is to do F5 for math, then choose the tangent down at the bottom, and then type in the number 2 because you only want the tangent at the value x is equal to 2, and then hit enter and it will give you the equation. Now the next question is, if they asked you for just the derivative first without a particular value, there is also a way to do that as well. You're going to do it in the home screen. I already have y1 typed in, so I'm going to use function notation for that in my graphing calculator. But the vernacular for it is that if there is a derivatives button, it has like the scripty letter D. You're going to put in the function. You want to find the derivative with respect to x, and then hit enter. Enter. That is actually what it will look like in the home screen. I'll show you how to find the D and also the function we've written in y1 of x, but remember you have to use function notation, and you have to tell the calculator, oh, this is what I want to find the derivative with respect to, because I can take the derivative with respect to any variable. So let's go to the calculator and have a look. So on the screen right now, we have the function. We're going to go to the home screen instead. As you can see, I've already been doing some of this, but to find the derivative using the home screen here, I need to tell it to actually find the derivative. So that's a calculus function. That's an F3. So F3, choice number 1 is to differentiate. So choice number 1, differentiate, and it does that funny scripted little d. The shortcut for that is above the 8 if you see it in blue. So I could also have just hit the second button and then the number 8, and it types that in so you don't have to go through the menu. I have already put the function in y1, so I'm going to type y1, but it only understands function notation, so y1 of, and I want to differentiate with respect to x, n parenthesis enter. And that gives me the whole function. Now, the thing with the TI-89 is that it will always give it to me in terms of cosine and sine. If I did it by hand instead, I would end up with a much cleaner looking derivative. If it's a free response and you are asked for the derivative and it's a calculator portion of the test, it does not matter for the AP exam that it's all in terms of sine and cosine. You can write what you have here in the calculator. Personally, I think it would probably be faster to do it by hand. Now, if I wanted to find the derivative like this at a particular value, then I would have to use the domain bar and say, okay, the domain bar is in the first column. It's like, it looks like the absolute value bar, but it's not an absolute value. It's like first column, fourth from the bottom is the domain bar. And then you would have to say, I want x equaling 2. So there, x equals 2, like that. It substitutes it in. I want it in decimal notation, so I could do the diamond and enter, and it'll give it to me as a decimal. We already knew that. Another way to tell it to do a decimal is to say x is equal to 2, and then put a decimal on the at the end. You see my active bar here. Just put a decimal on the end of the 2, and it'll give it to me as a decimal. So those are the possible options here. So I wrote out how to get some of these. Again, to get to the derivative, that funny looking D, it was in F3, the calc menu. So calc, menu, choice number 1, differentiate. Like that. That gets you that one there. Or the shortcut was second 8. That's a shortcut, like so. And the x and the equal sign are just on the front of the actual calculator.